Mike's hot. Hello. Hello. Good morning, everybody. How are y'all doing? Anyway, I've been clipped a little this morning from having some fun, so blame Chris Mullins, by the way. But I would like to say I just got back from New York, and I'm like every other Southerner, man. I mean, we stereotype New York. I hear New York, I just think New York City. But man, when I was driving upstate New York, going up towards Syracuse, beautiful. It was just gorgeous up there. Sometimes you forget. So it made me think about how we just have these stereotypes and things hung in our head, and it goes to a lot more than just geography. But so when I open up with the prayer this morning, that's going to be part of it. Is I just right now in these times right here, it'd be I think if we could be a lot more just open and understanding and listen to other people, I think we'd probably be a little bit better off. So I'm going to go ahead and pray real quick, and then we'll get rolling. Father, thank you so much for this time today. I appreciate you getting me back safe and sound from New York, and I appreciate the same thing from Ohio. I got back last night, and appreciate all the folks up there. Matt and them up in New York, and Ed and them down in Ohio, and just appreciate the chance to teach with the folks that are in this industry and to learn to do our jobs safer. That's the most important thing, Father. Also doing better, but really just safer, us getting home to our families. Family is so important right now, and Father, I just lift this country up right now again. I'm going to keep doing it, and because we've got some stuff coming up, but Father, as a Christian, I know I'm not worried about the politicians, and I'm not worried about anybody else because they're not really in control. You are, Lord. And I just thank you so much for everything you give us, those things we know, and those things we'll find about later that we didn't even realize that you stepped in for us and helped us and blessed us, Father. So all of these things I ask and say, according to the will of one who paid it all, my brother, Jesus Christ. Amen. All right, so today it would appear that we're going to do solar applications with self-contained meters. And it's funny because this has come up with a few of our customers here lately. We've had up there at Grid, they were just talking to me about it. And then we've also had some that have gotten hold of Chris separately. You know, we've been these issues with self-contained meters used on solar applications. So that's what we're going to be talking about today. Solar obviously is getting hotter and hotter and hotter. Everywhere that I go, when solar comes up and I ask, they all say, oh no, it's getting more and more and more. The guys in Ohio said that yesterday. And then also we're hearing the same thing. You hear it everywhere. You wouldn't believe it, Massachusetts is one of the biggest states for solar power. I mean, I was up there. We spent a whole day testing nothing but solar sites. So it's everywhere. You think it's just, out in Arizona and stuff. It's not anymore. It's everywhere. Okay, so I think this is a great application. Since we've had customers asking about it, different customers from different venues, separately to Chris and I, that's what we thought we'd do today. So we're going to be talking about solar applications using self-contained meters. Okay? So this is, wow, 14. Okay, webinar series 14. It's amazing. So today we're going to talk about solar, like we said, solar applications on self-contained meters. Then next week we're going to do demand metering, and then the next week we're going to do solar applications with transform rated meters. And we literally had another customer just talk to us this morning about solar applications with transform rated meters. So we're going to use that what we just heard this morning and apply it to what we're going to do 2 weeks from now. So the solar thing's been coming up a lot, and this is literally direct input from customers, so we love doing those. So that's what's going on coming up.
And actually, all three of these are customer suggestions. Every single one of them.
All three of them are customer suggestions. Thank you, Mr. Director. So Chris is the director and he's the producer. Or did I get that wrong? No, you're producer and he's director.
Yes.
Okay, sorry. And now that we're getting to the agenda part of it, the why solar, types of billing agreements, types of SC metering configurations, wiring diagram review, and troubleshooting demo, I will turn it over to Mr. Mullins with the agenda, and he will start into it, and then I'll be involved in the live testing. Thanks.
Thanks, John. What I wanted to talk about today was some of the, kind of getting ready as some of the utilities will start going down this path of having these solar applications, and what would a block diagram kind of look like as far as how am I going to feed the customer and what's the customer's expectation. I'll also give you some tips, installation tips, and I'll give you some ideas on how to handle these different scenarios. And I'll kind of start out with just kind of getting us into, why people use solar. For the consumer, there's a lot of benefits. You know, it's pollution free. There's no greenhouse gases affected with it. Not true for the manufacturing of it, but as far as the use of it, that's true. They reduce their dependence on fossil fuels like coal, other quote unquote dirty fuel, and they do get a better return on investment than paying utility bills for forever. So a lot of benefits for the consumer. For the utility, not as many. And unfortunately, the really main thing the utilities has to be able to handle it is that they're required. So they have this thing called Renewable Portfolio Standards, or you may hear this acronym called RPS. And so that really varies state by state. Some are more stringent, some are a little bit more lax. But if you're the utility and you haven't run across these RPS yet, you will. So hopefully this will get you a little bit prepared for it if this is something that's brand new to you. So there are two different types of solar power generation. You may have heard the term front of the meter or behind the meter. So front of the meter is the utility side. So, you know, over the last couple years, you know, the generation side has been trying to converge their older fossil fuel technology into more of a cleaner technology, and a lot of that's due to regulations from the U.S. government. But again, it's really varies state by state. So it's going to be on your side, the utility side, your solar array that you're using to generate power. That's what we're calling front of the meter. So that power goes to the customer really the way it is today. There's not much of a difference there. The big difference, though, is the second one, which is what we call distributed generation systems. You may see it called DG. It's an acronym, but we call that behind the meter. So this is what is catching on the consumer side, because if they want the ability to eventually kind of disconnect from the grid completely, this is the direction they're going. So this is going to be your roof panels. This is going to be your energy storage. Your microgrid, you know, a lot of the some companies like Tesla, for example, they're creating their own storage, battery storage, you know, packs where you can actually put them on your house, and you can be disconnected from the grid totally. It seems to work fairly well for residential, but they haven't got there yet on the behind the meter side for commercial industrial. So they haven't seen that kick up as much as they have on the residential side. So here's some good metering configurations on the self-contained side. So you've got a 12240 single phase 3 wire for like a 2S bridge. That would be a particular installation where you can use a typical residential meter on a bridge, which is barely just a communication port between your AMI or your smart grid. You can do the same thing for the 12S and the 16S, as long as your project size is less than 60 kW. Once you increase that size to over 60 kW and up to 500 kW, if you get up to that size, you're probably going to have to CT it no matter what. But if you stay at a little bit lower, you start using the same meter forms of 2S, 12S, 16S, residential for 2 and 12, somewhat light commercial for 12, and then 16S will be your commercial. Those are going to be your demand meters, or the interval state. That's where you pull your interval data from, or use it as a demand meter. You may have heard this term called PV, and that's the photovoltaic system. So that is the system used on the solar side that actually converts the DC current to AC current, so it gets the meter so we can measure it, right? So that's what, when they say PV, that's what they're talking about. And when that gets the meter, that meter has to be bidirectional, because it can be either delivered or received. So when it's in receive mode, that means that the solar panel is actually generating power and the meter is turning backwards, right? And we'll start talking about the different kind of rate structures when we get to that point.
And Chris, we showed on earlier webinars, right, where we had the reverse flow on it, and remember we had one meter that wasn't bidirectional, so it wouldn't give us anything.
So
When we were troubleshooting before, we said that could be an issue. Yeah, unbelievable. You would think, no, surely not. But yeah, you could go out there and they could have a non-bidirectional meter trying to measure this, and it's not going to work.
Yeah, you would get 0 kW.
That's right.
Basically.
That's
And at night, maybe you get some consumption.
right. That's right.
But forget it during the day. Here's an example of a PV system. This is it's wired in with a 2S meter. On the left, that is your inverter. That's your AC to DC inverter. And then the metering, that is the utility point, the revenue point there. And then on the far right, that's your breaker box you've got for the system. I think this one was actually at a park. But I'm starting to see more and more of these inverter boxes where what they're doing is really supplementing. They're not really, in this case, this will be called, I guess, front of the meter, because they're just supplementing. They're actually getting one metering point from the utility, but it's supplementing some of their bill costs by using this to do, instead of just 100% consumption. Two rate structures that I've found. Maybe you guys can let me know if there's any others out there, but there are two ones that I've found that I think most utilities use, and by far the most popular one they've been using is what they call a buy all, sell all. Obviously, they use the bidirectional meter, so we can measure consumption, both delivered and received. So what the utility does, it sells that power to the customer at their typical retail rate. So the customer has on their side has a solar system, and they're generating power, and they're sending power back on the grid. But the utility sees that, all right, got it, but I'm going to pay you at a cheaper rate, right? So it's not a one-to-one.
No.
So the utility is actually making money in this case. They're selling it to the customer, and they're selling it at a cheaper rate to the consumer when he puts power back on the grid. Net metering, very different. Still use a bidirectional meter. The methodology is the same, but the problem with net metering is what it is net. So the idea is that they want to have zero consumption. So the consumer wants to balance out what the utility is giving them. So the way that it's structured is the rate is the same, which is retail, and they sell back retail. Not very lucrative for the utility, so it's not as common as the buy all, sell all structure is. So if you do have to run across these behind the meter installations, and the intention for them to do this is to get off the grid, how does utility recoup these costs? Because they're not going to get the monthly income. So a couple ways you can do that. You can, when you go out there, you still have to have a metering point between the where it's delivered. So there's no way they can back out of that. So you can charge for the meter and the installation fees to go out there. You can actually create a portal, which is think of it like an online form. Instead of these consumers calling the utility hotline and kind of taking up too much time, you can actually force them to go to a web page, fill out what they need, and that goes into a queue where you can actually start on the work orders as they come in. It's a better way so it doesn't bottleneck into one person handling it at the utility. A lot of times these consumers are not professionals, and they're definitely not electrical professionals. So they're going to need some consulting. So you can obviously make some money with your engineering staff to go out there and consult for them and get a little bit of money that way. And you can require them to have a second meter socket, which will be the revenue metering point. So if they ever go back to where they still need that metering point and they want to go back on the grid, you will have that, and you can always capture it at any time. But it has to be accessible, so the utility worker has to be able to get to that meter, and it can't be enclosed in a house or anything. So I'm going to go through a couple examples of, I'll call it, this one I'll call a resi, light commercial, which is 1S, 2S. And this is a behind the meter example. Jared, you said that they can see my mouse?
Yes.
Okay. So I'm going to start backwards. So here is my distributed generation. Think of this as my solar panel, right? Goes to my inverter, converts that DC to AC. Now I've got this smart metering point. And by the way, these configuration diagrams are from a customer of ours named Eversource. They're actually up in Massachusetts, and they're a large utility up there, and John is exactly right. For some reason Mass has really picked up, and I think it's because it's a statewide system where they're trying to get everybody to use the renewable energy. So they've been using this, and so I kind of grabbed it and borrowed it in quotation marks. So again, here's your solar panel, goes to an inverter. This goes up to the what they're calling a smart metering point. Really, that's just kind of the sub meter, and this is bidirectional, obviously. This goes back up to the utilities disconnect, and then here's my point of connection between the main. Here's my main here, and this goes back out to the line, the rest of the line going further down the line here, and then finally, after I get past the main breaker or the main service equipment. Now I got a one switch, here's my revenue side. And of course it's bidirectional where. So this is where you're gonna be testing, right? So whenever you go out to a site, you wanna verify, this is where you're gonna verify the revenue point. This is really more for consumption. There's no necessarily, maybe you need to test it just for functionality, but really your revenue is all coming from here. This feeds it back to the utilities billing system. So that's a resi small commercial that has just a solar array. Slightly more complicated when they add a battery storage. Still the same principle, because you still have to have an inverter in between this consumption meter here, between your solar array and your battery storage here. So very similar situation. There's nothing much difference other than we're just adding another piece to this, so it's in line with that consumption meter, right? So let's look at a commercial side. This configuration could actually apply to a 16S, probably around 60 kW. I wouldn't go much more than that, but if you go over that, you'll have to CT and PT it. So this will work for both transfer rated and your higher end self-contained, possibly your class 320 16S meters will probably work on this. But notice the difference here is that I've only got one single meter. If I go back and look at the behind the meter, I've got that consumption meter and I've got the utility point. But in front of the meter, I've just got one single metering point, because this is the customer is actually buying from the utility using renewable energy supplied from the utility. So much simpler. There's not a lot of complexity here, other than really you got this solar panel here, an inverter, and that goes to a disconnect switch, and this goes to the main panel, and then back up to the meter. So from a metering point of view, there's very little difference. Now, when we get to the actually live demo, when John hooks up the PowerMaster, you can kind of see where the difference is then. But if you walk up to it and didn't know it, you would never know it was a solar site, right? And the same thing with the battery storage. You just have another battery storage in line with your solar panel here, and it's still got the AC-DC conversion all the way back up to the metering point. So that one is fairly simple compared to behind the meter. Behind the meter is much more complicated, but I think this one is much more beneficial. The front of the meter is obviously beneficial to the utility. A couple of tips before I turn it over to John. Remember I mentioned that if it is in front of the meter and you walk up to it, you may not even know. So clearly identify it. It's really more for the maintenance guys coming up there to want to be able to go out and test it. They need to know this information. So just something as simple as just putting a solar or solar production or something, or solar generation somewhere on the meter can to let the next technician know that's what's going on. And for consistency, this is a rule of thumb. This is not a standard, unfortunately, but if you're coming in from the top side, let's say on a 16S meter, coming in from the top side of the meter socket, you want to point that towards your utility feed, and then on the bottom side or load side, you're going to point that towards the solar generation or the battery storage to the customer. Again, not a standard, but a good rule of thumb to keep your consistency. So now I'm going to turn it over to John, and we're going to test a 16S and see what does that look like when it's in generation mode.
I have a question first.
Yes, sir.
Those inverters and the switching and any of that stuff, does that affect our power factor, or does that impact us as a utility?
It will affect your power factor horribly,
Yes.
and it will add many more harmonics on the side.
Exactly. Right.
I would love to get one in here in-house so I can actually simulate it.
That's right. That's right. All right. And I know that I'm going to catch a little grief about not having gloves on. I lent my gloves out, and the ones that they brought in here for me can barely get over my hands. So I already know. So I know the guys are going to light me up about it, literally. So just, I know. Okay. So what we've got here is, you can see over here, I've got my 16S. So we've talked about this on previous webs. That so when we're testing this 16S, we're going to do a customer load test on it, which is this is the way we can see what's going on. Talking about the solar. Then what I've done is I'm using these clamps right here, these 353 clamps right here. So I'm using clamp-ons because I have nowhere to put the duct bills, right? There's no test switch involved with the self-contains. So I'm using these to get my current. So I'm here on A, B, and C. I just got to make sure I get my arrows going the right way, right? There's still arrows on there just like there are on the flexes, just like we know everything that we use on these current probes are directional. So there's usually arrows involved, or we know with our high volt probe, the U that goes on the end of extendo, my little goofy thing in my P-brain so I can keep it straight is a label towards the load. So you have to have it the right way. If you flip it the wrong way, you'll get polarity reversal. So we've got our arrows going all the right way because my current's coming in here. So I got my arrow going up right here. Okay, so and then I've got my voltages are connected down here, A, B, and C, and I'm over here with my bonded ground over here on my neutral. Okay, so I've got all my connections are made here, and I can see that this one's hot. So, so I'll come over here to the screen, and you can see we set up a site 16S, so we've got it sitting right there, always up in the upper right-hand corner. It tells you what site you're on. You know that's the Powermetrix way, so we always have it up there for you. So on this site now, this is probably a little bit more of an advanced class, so I'm not going to go through setting up the site and all that. You guys know all that. Let's just get to the meat of it. So I'm going to go ahead and hit number 3 for meter testing. No, I'm not. Remember the rule that I always try and say is let's look at the vectors first. So let's take a look at the vectors first before you jump into the test, because once you get in there, you can't, now in this case, we're not going to be toggling between primary and secondary, but if you just get it in your head, we talk about this in the field all the time, me and the guys. If you do it the same way every time, you make less mistakes. That comes to just hooking up your connections over there at the meter, okay? Same thing with this. Always look at the vectors first, because if you see something, you might need to back up. And remember, I just told the guys yesterday in Ohio, I always default to John first. So if I hit my vector button first and I see something screwy on there, I always think John first, and I make sure I don't have a flex in backwards, or I don't have one of my connections wrong. And then once I see that that's not the case, then I can investigate a little bit. If it's a transformer rated site, I'm going to go ahead and toggle to the primary and take a look at it, okay? Because remember, secondary follows the primary. So if I have a problem on my primary side, it will follow over to that secondary side. So that's why I go through that. So let's do that. Let's go ahead and hit my vector button. So everything looks okay. So my vectors look all right. So everything looks okay. So I can go ahead. Everything looks good. So I'm going to go back to previous. And let's go ahead and just run a standard. This will be what it should look like normally. Okay, so I'm going to go ahead and run a normal meter test. So I'm going to hit number 3. I'm going to do a customer load test. And you know I've talked about this before. I always make that 30 seconds or 3 revs in case there's not much load there. Because when I have hardly any load, it's usually when it's 95. Okay? What do you give him? Is it a thumbs up, a thumbs down, a thumb sideways? Oh, no, that's an index finger. Now I can go, okay, all right. It wasn't the other finger, by the way. Okay. So, all right, so Mullins was giving me hand signals I didn't quite get. I didn't play baseball. Sorry. All right. Quick shout out, Ryan Smith in the back there. Go Braves. He loves the Braves and they won, so he's all tickled today wearing his Braves hat since I brought up baseball. Okay, so you can see here, this is that standard wiring diagram we see all the time. So we look all right there. So let's hit next. And we'll start and do a test. So I've got my pulse. Remember, same rule. Until I get this lit up and get a pulse here, start test doesn't come up. And since the Professor Ray Gore taught me to always wait for a second pulse, I'm going to wait for a second pulse before I hit it. There we go. So now I'm going to hit start test. And this is the same old rule we always talk about. Pulse is actual versus pulse is expected. So it says I'm going to actually count them out with my pickup over there. The pulse is actual, 1, 2, 3 within the 30 seconds. But then it's going to measure it and say, well, actually off of what we measured, this should be the number of pulses. So since we're talking about solar, and since I know how Mullins is, I'm guessing Mullins switched it on me in between this. So it looks to me like Mullins switched it over from the normal to a solar now, and so he's put it in there so that you can see. You remember we was talking earlier about getting that negative % registration? Well, the reason we're getting negative % registration is we're seeing as what? We're seeing this as received instead of delivered. Okay? And you remember, I'm going to jump off here for a second. If you're doing a phantom load test, you remember we went over all that where you can change it from delivered to received on the phantom load test. And in these situations with solar, we have a lot of folks they'll run all 3 tests on the delivered and then all 3 tests on the received to see how much they've got on each. Okay? So in this case, it says a negative 100.782. It's not liking that. Okay, so what I'm going to do now is I'm going to go previous here, and I'm going to look at my, well, no, let's just do it straight here. I'm going to look at my vectors. Well, that would explain it, wouldn't it? So if I had seen that on the front end, you remember I always look at the vectors on the front end, I would have immediately seen, let's say I would have done this first. Okay? I appreciate the curveball from Mullins, but let's see if we'd seen that first, we'd have thought, okay, what are some possible, remember, we're trying to do this as techs in the field of thinking all the possible problems that you could have, and then what can I throw out because no, I know that's not right or that's not right. So what ones do I have? Someone could have wired all the CTs backwards if this was a transformer rated site, right? It's not, but I'm just saying, let's throw out possible. What do those vectors look like? Those vectors look like every single phase is going the wrong way for some reason. I've got polarity reversal seemingly off of the vectors. That's what they look like, polarity reversal on every phase. So I could have wired all of the CTs backwards if this was transformer rated. But in what we're talking about today, remember, the flow is going the wrong way now. I'm receiving instead of delivering, so it's going to show that as polarity reversal in every one of those phases right there. And remember what happens when that happens. You can see there I've got negative power factor on every one of those.
And it's not that unusual. Let's say you're out, and I've seen it happen before. You're out at a solar site, and you're out there testing, and cloud comes over. Now you're going to start seeing your power factor shift because it's shifting back from delivered to received. Mm-hmm. It wouldn't be as quick as what I simulate here, obviously. It wouldn't be like boom, boom. That's but right. You're going to see a slow shift as it goes out of generation mode to back to receive mode.
And here's one for you. What if I was out there in the field and I hit this button? Remember, we're following we'll call it the John rule. The John rule. Hit your vectors first and look at them first before you get into the test. So if you follow the John rule and you look at the vectors first, and then you run the test and you got your registration looked good, but you had seen this first. You saw the vectors all looked 180 degrees out. And you're thinking, wait a minute, why don't I have a negative % registration? There are some utilities that they have changed, right? On their system, they've changed it so that it'll come out to be a positive registration. Even though it should be negative, they'll make the changes themselves. We know utilities that do that, so that even when they go test a solar site, they still get positive registration. So for whatever reason, that's what they wanted to do. So they've changed it so they don't get any negative registrations out there. They've, on their part, the utility has made it so that when you go test that meter, it's going to come out with a positive registration no matter what. Okay, so just in case that has happened, let's say you're a third-party tester. I don't know who all I'm speaking to out here. Or you are with a utility company who just didn't know it. That could happen to you. You could go out there and look at those vectors and see every one of them out 180 degrees, and you're going, uh-oh, I think I got a situation here. But wait, oh, this is solar. But then when you test it, it comes out 100 point whatever. And you're thinking, wait a minute, how could that be? You might check because they might have done something. You go back in there and check with them with your IT and your system folks, and they may have set it up so that it's always going to come out as a positive registration. Okay? So in this case, that makes sense on what I got on the negative % registration, right? Because every one of them are seen now because it's solar and I'm receiving and not being delivered. And it's a bidirectional meter, so it's saying, yeah, that's no problem, I can measure it, but I'm going to make it negative because I'm receiving it now and I'm not delivering the power. So the vectors match up with what I saw on the registration, right? If every one of those is out and I got nothing but negative power factors, you can believe it's going to come out negative watts on every one of them, right? Every phase is going to come out because I'm multiplying by a negative power factor on each phase. So I'm going to come out with negative watts, so it's going to give me negative registration. Okay?
Too.
Much higher VARs. Good. So there we are like that. I'm going to hit done with that one. And we're going to move over to the 12S, correct? All right. And while I'm making my connections over on the 12S, Mullins is going to tell you a joke.
I don't know any jokes. I'm not in sales.
It was just great to see the look on your face.
What do you call
Uh-oh.
a bat with a bell?
Here, say it again.
Oh, no.
What do you call a bat with a bell?
What do you call a bat with a bell?
Oh, no.
It's a dingbat.
It's a dingbat. It's a great Halloween joke.
How old's your son?
Could be 3 in January.
3 in January. He's on the floor rolling. That's a good one. All right, so we're going to go A and B here.
So everyone, he is hooking this up dead. So there's
Yeah.
nothing live.
Okay. Okay, we should be fine now. Yeah. Oh. So I'm going to go over here and make I'm going to select the site, but I'm going to change it to the 12 from the 16. Cool. So you can see up in the corner, 12S. Got it on the correct site for us. Start test over here. Cool. So we got hot light. So we got a hot light. So we know, and you can see where I've made my connections here. I'm on A and B phases. So I'm over here. I've got my, you can see I've got my clamp-ons. So I've got this one right here. I've got A phase right here. I've got my A phase right here, and I've got my B phase over here, and I've got my neutral connected right there. And then I've also got my A and B phases there and there, okay, for my voltages. All right? So we'll come over here, and we will do we're going to take a look at our vectors first.
see a purple.
Everything looks good. So that's the normal vectors that you would see for a 12S, right? But then suddenly someone connected them to a solar site. So Mullins from the admin station hit the buttons, and now this is what you would see if you had a 12S and a solar situation, right? Or once again, we would talk about, all I know is by looking at that, I'm the tech and I'm looking at that and I'm telling myself, I know that it's backwards. Flow is backwards. All this whole thing with electricity, flow, flow, flow. That's why all these things are directional, all the sensors. So in this case, I can see 180 degrees out on both A and B phases. That's going to indicate, once again, if it was CTs, they're wired backwards, don't have CTs on the 12S. So in this case, this is looking exactly what we're talking about, like a solar site, right? And that would be, I know it sounds silly, but that's when you might go ask them. You know what I mean? There might be solar there you don't even know about or someone hadn't told you about. But that would be one of the things you would think right there. That looks solar, okay? If it was three-phase, maybe all three CTs were wired backwards like we talked about. But in this case, it's starting to look awful solar-y. So let's go previous. We'll go ahead and run a customer load test on it and see what happens. So I'm going to go 3 for meter test. I'm going to go customer load, number 1. And remember, I always go my 30 seconds or 3 revs. And I'm going to hit next. Okay, Jared, I do have a joke. Here's the thing. Should I tell it this one or the next one? Your call.
What's the question?
The question is, I do have a joke, but should I tell it today or future? I'll let you make that call.
Tell today.
Okay. So here we go. So we're looking for pulses. And per the professor, I'm going to wait for that second one. Come on, darling. One time. One time. There it is. So what do we think we're going to see there in the chat room? Are we going to see positive or negative % registration? Drum roll. Oh, negative, right? Remember, it's a solar site. Everything's going in the wrong direction. This coincides with what my vector showed. If I have polarity reversal on all phases, I have nothing but negative power factors to multiply times my voltage and my current. So I'm going to end up with nothing but negative watts. So guess what? I'm going to end up with negative % registration here. So I've got negative % registration, and should have one more pulse if it's within 30 seconds. If not, she'll time out. Nope, we got another one. So just a quick note. Why do I have that message down there at the bottom? It says, test complete, possible error, please check connections. Why is that? In case you ever get that at the bottom of the screen, my 100.568 does not fall within what I set up as my pass or fail. So remember when we were talking about setting up these kits, going into the utilities and setting up what's pass or fail on your meter, what's pass or fail on your CTs. If you set that up, clearly we've set it up so, and I know that, if I'm using someone else's machine out there in the field with them and I see a fail like this, you can look at that and kind of tell where they've got it set. Like if it had passed here, I'd have known they'd have upped theirs a little bit, right? They'd have given that margin a little bit greater for pass or fail. On this one, I know right now, this one is definitely less than 0.5, right? So what's pass or fail on it? So I'm getting this down here at the bottom. It's telling me it doesn't like it, okay? Because it doesn't fall within that range of pass or fail that we set up in the test kit, okay? So we got the negative % registration because once again, solar site, all the power factors are negative because the machine and the utility sees all that as polarity reversal. Received power instead of delivered power. Okay? Okay. So, what did we learn today? Oh, okay. Click again. So we learned that solar sites, we learned that they're more and more they're coming, right?
talked about the difference between front of the meter and behind the meter.
Yep, between front of the meter and behind the meter. Behind the meter is when someone wants to get off the grid and have their own deal. But front of the meter is where the utilities are. It's all run by the utility, and this is all of the solar part of it is all the utilities. When it's behind it, that's where somebody wants to go off grid. Okay. We also talked about how it affects us. It will affect you on your power factor. It will affect you on your harmonics with those inverters. Okay, the AC/DC inverters affect all that. We also talked about what it looks like on the machine. It's going to look like, if you have a bidirectional meter, it will work fine, but it'll tell you now it's negative registration because it's telling you I'm receiving power and I'm not delivering it. If it's not a bidirectional meter, it won't give you zilch. That's when we've seen error scenarios before where it was going the wrong way, remember, on a non-bidirectional meter. I think it was our 5S, and it went belly up. It wouldn't give you a pulse, right? Because it doesn't see anything, because it's not bidirectional. So if it's not delivering power, it's not going to work. Okay.
For our upcoming session on transfer rated sites, we'll go into more of the detail, the power quality issues you're going to run across.
Cool.
Yeah.
Cool. Okay, so we will go into that a little bit of the
Yes.
stuff we're talking about between the harmonics and the power factor and all that stuff. Great. And so here on the self-contained stuff, since we don't have, the CTs and stuff aren't involved in it, you can still, though, remember, we still are going to look and follow the John rule and look at those vectors first before you go into the test. And you would have seen all of them showing polarity reversal, every single phase. So unless someone on a transform rated site, I know I'm jumping a little bit, unless someone wired all the CTs backwards or something, this would have to look to you to being pretty deliberate, so then that make you think solar. Okay, if every single one of them, if that's the difference between that and just one of them showing polarity reversal, then you might think that's another issue. But every single one of them, all showing polarity reversal, yeah, that would make you think solar. Okay, and so just and if it's a bidirectional meter, it is going to give you that negative percent registration because it will see it. So just remember that, and check if you see all of that 180 degrees out on everything, but you go to test that meter and it tests fine. It shows, 100 point whatever percent or 99.98%, and there's no negative there. Check with someone in your company and make sure that they haven't rigged them so that they will always show positive registration. Okay? And so I guess since I've been requested by Jared, I will tell my joke right here. So, wait. Well, you know what's coming up. Demand metering next week, and week after that, we'll hit the transformer rated solar applications, okay? All right. So, guys going down the interstate back, not that long after 9/11, everything's cracking down, all this, everybody's kind of on high alert. So, guys coming through Knoxville here on I-40, and he's got a brake light out, so state trooper pulls him over, and he says, talks to him, looks at his, all of his information, says, "Is there anything in here I need to know about? Anything in the trunk or anything?" The guy says, "No," but trooper doesn't really like the look of him, so he says, "Pop the trunk." So he pops the trunk. When he looks in there, there's axes and machetes and chainsaws, and he says, "Hey, you need to come back here for a minute." So the guy comes back and goes, "Well, what's all this?" And he says, "Well, I'm a juggler." He says, "You're a juggler?" He goes, "Yeah, I'm a juggler." He goes, "You juggle chainsaws and machetes and axes?" And he goes, "Well, yeah." He goes, "Well, I'm going to need you to demonstrate that." The guy's, "Well, okay." So right there on the side of I-40, after a couple minutes, this guy's got a chainsaw, a machete, and an axe going. Well, right then, Jim and Billy are driving by in their pickup truck headed to the game, and they watch this as they drive by, and they get about a quarter mile down the road, and about that time, Billy rolls his window down and he pours his beer out. And Jim goes, "What are you doing, Billy? That was a cold beer." And he goes, "Man, I think my drinking days might be over." He goes, "What in the world are you talking about?" He said, "Son, have you seen the field sobriety test they've got now? That guy was juggling a machete and a chainsaw." Anyway, so I made your chuckle. I win. Okay, so we really appreciate everybody. Thank you so much for the folks. I was up there in New York and Ohio this week. They were very gracious to me, and we really appreciate that. And we appreciate any chance to teach and train. So any opportunities, please holler at us, okay? But be careful out there, and God bless y'all.
Thank you.